I rebuilt one reasonably large app twice, first with GSD, then with OpenSpec using the same brief, GPT 5.5 with median reasoning effort, and the same Codex CLI version. I expected a difference because these frameworks have different philosophies. I did not expect the numbers to look like this. OpenSpec finished in 1 hour and 52 minutes. GSD took 6 hours and 46 minutes of elapsed time, including the abandoned Claude Code start and breaks. Even if I only count the successful Codex rerun, it still took 5 hours and 25 minutes of elapsed time. That is not active typing time. I took breaks, and GSD sometimes worked for long stretches on its own. I did not measure exact human minutes, so I will not pretend I did. At first, I thought the usage screenshots would be the best evidence I had. Later, I parsed the local codex logs and the gap got even clearer. OpenSpec spent about 35.3 million tokens across 6 threads. GSD spent about 126 million tokens across 38 threads. Based on the numbers, this should be simple. One tool was much faster and used far fewer tokens. Except the final repos made it complicated. From the browser, the two apps were surprisingly close. I could sign up, sign in, edit profiles, publish stories, post comments, send direct messages, check unread messages, and open the leaderboard. If only I judged the result by testing the UI in the browser, the faster tool would win right away. But when I opened the codebases and compared what was left behind, the slower run started making a better sense for itself. Not through the UI, but through the project baseline. This is what this video is about. Both frameworks can generate a demo app. The more useful question is what you get in exchange for the extra process and whether that exchange is worth it. GSD and OpenSpec are not tiny GitHub experience in terms of attention. At the time of this test, GSD has 59.4 thousand stars and OpenSpec had 44.8 thousand. For a niche category like spec-driven development, this is a lot of attention. It makes the comparison more useful than reading two readmes and picking the one that sounds nicer. I also did not want to test them on a toy app. A landing page, a to-do list, a small cat game can tell you whether the command works, but it does not really test the framework under pressure. The point of these tools is structure, requirements, planning, implementation, verification, follow-up changes. I needed something large enough to force the tool to manage many features at once. That project became NewWriter. The original version was a website I built with a friend in 2010. It ran on Drupal 6, which was already not exactly young by the time we were done with it, and over time it grew into a real community of writers. People came in, published stories, commented on each other's work, built profiles, sent messages, and generally did what communities do when they start existing without asking your permission first. Eventually, we had to shut it down. The site was Russian-speaking, the stack was badly outdated, and after the war started, pro-war opinions on the platform made the whole thing impossible to continue. I do not want to revive that community in that form, obviously, but the product idea itself stayed in my head for years. A clean, modern writing community rebuilt from scratch on a modern stack. That made a good test brief. The app needed authentication, writer profiles, avatars, story drafts and publishing, markdown rendering, categories, comments, direct messages, unread message counts, a leaderboard, a homepage and seed data. Not enterprise software, but definitely more than a tiny demo app. This is the PRD I gave to both frameworks. Before the actual runs, here is a quick refresher on how these frameworks expect you to work. One small but important detail: command names depend on the host tool. In Claude Code, OpenSpec's current docs talk about OPSX command like /OPSX:propose. In Codex, at least in my project, the generated skills had not been renamed yet, so they showed up as $OpenSpec propose, $OpenSpec apply change, and $OpenSpec archive change. GSD is the heavier lifecycle framework. You start with GSD in your project, usually with --auto, if you wanted to read a PRD and make reasonable assumptions. That creates the planning state under .planning. Project notes, requirements, roadmap, research, phase folders, and the current state file. After that, the long flow goes phase by phase. You discuss the phase with GSD discuss phase, plan it with GSD plan phase, execute it with GSD execute phase, verify it with GSD verify work, and eventually ship it with GSD ship. There is also GSD next for detecting the next step, GSD autonomous for chaining more of the workflow, and GSD quick for focused fixes that should not become a whole project phase. GSD does more than write a spec and hand it to the model. It tries to run the whole project. It creates requirements, roadmaps, phase plans, research files, summaries, and verification artifacts. It can also use sub-agents, so different parts of the work happen in separate contexts. This is why I kept saying during the test that GSD feels like what BMAT should have been. There is process, but there is also automation behind the process. OpenSpec is much smaller conceptually. The core loop is OpenSpec propose, OpenSpec apply change, and OpenSpec archive change. Propose creates a change folder with proposal MD, design MD, tasks MD, and delta specs. Apply works through the task list. Archive merges the delta specs into the canonical specs. For a small change, this is basically the whole flow. For a larger app, OpenSpec does not naturally create the full project roadmap for you in the same way GSD does. You split the app into several changes, then apply them one by one. That gives you less orchestration, fewer artifacts to manage, and less time waiting for the framework to decide what the project is. The shortest version is this. GSD wants to own the project. OpenSpec wants to own the change. Quick pause before we get into the actual runs. If you like this kind of practical AI coding test, subscribe to the channel. I'm trying to make these comparisons useful instead of just reading product pages back at you. And if you want to talk to me or other community members, join the Discord. It is still small, but that also means it is actually possible to have a conversation there. The link is in the description. The GSD run started in Claude Code, and honestly that first attempt made GSD look better as a framework. It asked more setup questions, it used sub-agents on its own. The whole thing looked closer to the architecture GSD was designed around. The main context stayed focused on orchestration. Specialized agents handled research, planning, execution, and verification. The framework kept state in dot planning. The problem was not the workflow, the problem was limits. I was on $100 Claude Max plan. That had been enough for serious coding before, but I had worked heavily that week, so the weekly limits were already drained. A sub-agent heavy GSD run was not something I could comfortably finish there anymore. At the same time, Codex had a promo running through the end of May 2026 with double usage on the $100 Pro tier. After June, that means the available usage should drop back to roughly half of what I had during this test. But for this test, Codex was the practical place to finish. So after about an hour and 20 minutes, I restarted from scratch in Codex. That first attempt was not wasted. By then I understood the GSD process much better, but it still showed something important about this test. GSD's preferred architecture can become expensive when the host tool has tight limits. In Codex, the project completed. It went through the major phases: foundation, auth, profiles and story publishing, public discovery and comments, messages and leaderboard, then seed data and final polish. The final app had the expected surface area from my manual acceptance pass: sign up, sign in, profiles, avatars, drafts, publishing, markdown, categories, comments, direct messages, unread badge, leaderboard, homepage, and seeded demo data. The run was still not smooth. Codex did not use sub-agents as naturally as Claude Code did, so I had to explicitly tell it that agents were allowed. Context management mattered in a very practical way. Fresh session helped, and I had to verify the app after phases instead of assuming the plan meant the result was correct. Several times GSD disappeared into a long phase while I waited for the stop sound and came back later to review the result. That last part is where GSD is much better than BMAT, at least for me. I do not like slow human-in-the-loop workflows where our agents mostly pretend to be different roles. One acts like a PM, another acts like a planner, and my job is to read a long document and press a button. GSD can run in auto mode and do a meaningful chunk of work while you step away. Set a sound when the turn is done, come back, review the result. That is a workflow I can live with. The cost is that these chunks are large and slow. OpenSpec iterations were much faster. GSD felt more autonomous and more disciplined but slower to adjust. The upside is that GSD left behind the stronger repo. It had test, typecheck, lint, build, and Prisma generate scripts. It had 4 actual test files. It used database URL instead of hard-coding the SQLite path. It had cleaner helper separation in a few places, and the avatar upload path used a better file name strategy instead of leaning on the original file name. So the GSD story is not slow and bad. It is slow, heavy, and technically more serious than the browser results alone would suggest. The OpenSpec run felt simpler from the moment the integration was in place. Installation itself should be straightforward for a normal setup. Install the package globally, run OpenSpec init, select codecs, and it creates the OpenSpec folder plus the generated skills. The small install fiction I had came from my local Mac user setup, not from OpenSpec itself, so I would not hold that against the framework. In this project, the codec skills showed up as OpenSpec propose, OpenSpec apply change, OpenSpec archive change, and OpenSpec explore. That is slightly confusing because the current Cloud Code docs talk about OPSX command like /OPSX:propose, but for the actual codecs run, these were the names I used. The workflow itself was simple. OpenSpec creates a change folder with proposal.md, design.md, tasks.md, and delta specs. Then codecs applies the change, you check the result, archive it, and move on. For a project this size, the cleanest approach would probably be to ask an LLM to split the app into phases first. That plan could live outside the framework as a small markdown file, and then each phase could become its own OpenSpec change. I did not do that upfront. Instead, I prompted OpenSpec to implement the first phase, and during that planning and implementation flow, it created 3 additional proposals for the remaining work. So when phase 1 was done, I already had the next 3 changes proposed and ready to apply. That helped, but I still felt more responsible for steering the roadmap than I did with GSD. The first foundation change produced a runnable app at localhost 3000 with authentication, Prisma SQLite, seed data, public pages, categories, profiles, and follow-up changes prepared. Some features were still stubs, but the app looked real much earlier than I expected because there was already a browser visible product instead of only planning files. The later changes filled the rest: profile editing, avatars, story, authoring, comments, private messages, unread message counts, leaderboards, homepage blocks, and final acceptance. The final acceptance paths used Playwright, found small issues like favicon and narrow screen layout bugs, and fixed them. OpenSpec was weaker on the repo baseline. The app worked, but compared with GSD, it left less engineering scaffolding behind. There was no test script, no type check script. The Prisma setup hard-coded for SQLite path despite having an env example, and some logic lived more directly inside routes and actions. Nothing catastrophic, but if I had to continue one of these repos tomorrow, I would trust the GSD baseline more. OpenSpec felt fast, lean, and easy to steer because the loop stayed small: propose, apply, check, archive. Then prompt the next change. The strange part is that the visible apps were much closer than the workflows. By the end, both implementations had the core NewWriter features. They had sign up and sign in profiles, avatars, story drafts, publishing, markdown rendering, categories, comments, direct messages, unread message counts, leaderboard, homepage blocks, and seeded demo data. If I opened the 2 apps in the browser and tested the main user flow, the difference was not dramatic enough to explain the time gap by itself. The problems were similar too, which matters. Both frameworks missed form preservation at first. If a login or sign up failed, the app did not keep the entered values in the way I expected. Both also had awkward comment behavior after posting. The comment existed, but the page did not reveal the new comment cleanly, so the result was easy to miss. The unread message batch was a slightly different case. I did not explicitly put it in the spec, but once direct messages existed, it felt obvious that the navigation should show unread messages. Both versions needed a follow-up for that. There were also bigger production concerns that go beyond this comparison. Avatar upload validation was not something I would call fully production safe, and neither app had serious captcha or abuse protection. I do not treat that as a framework failure because this was outside the realistic scope of a single generated comparison run. For a real public writer community, I would probably outsource authentication and user management to a proper third-party service instead of pretending this is a small feature. It costs money, but auth is a huge thing to build and maintain properly. I would not call that a framework failure. This was a lot of app surface for one generated run, and the observed UI issues were fixable through prompts. My read is that some of this came from the brief, the model, and the product complexity, with GSD and OpenSpec only being part of the story. So when I compare them, I do not think the main question is which one generated fewer UI bugs. The answer is not clean enough to be useful. The better question is, after the bugs are fixed, what kind of workflow did I have to go through and what kind of repo was left behind? This is where I'm going to put the scorecards on the screen. I rated both frameworks with the same evaluation categories: spec quality, plan quality, implementation quality, first result, polish cost, developer experience, adaptability, and verification discipline. These are judgment scores from this run, not a universal benchmark. The category table is what makes the score auditable. The final number by itself is not enough. GSD landed at 7.5 out of 10. OpenSpec landed at 8 out of 10. The score might not look strange if you only heard the part about the repo quality. GSD scored higher on spec quality, planning, implementation quality, adaptability, and verification discipline. It produced better planning artifacts. It had a real quick flow. It left behind tests and type check. It looked more like a framework that wanted to protect me from sloppy engineering. OpenSpec scored higher where the day-to-day experience was better. First result, polish cost, and developer experience. It got a convincing app much faster, used fewer moving parts, and kept the feedback loop short enough that I did not feel trapped in the workflow. The token table makes the cost difference very visible. From the parsed codex logs, GSD spent 126.0 million tokens across 38 threads. OpenSpec spent 35.3 million across 6 threads. GSD spent about 90.7 million more tokens, or roughly 3.57 times as many. Using GPT 5.5 API pricing from May 2, 2026 as an estimate and counting cached inputs separately, GSD comes out to about $103.99 API equivalent. OpenSpec comes out to about $27.71. Reasoning tokens are included in the output token bucket in these logs, so I'm not counting them twice. That was not my actual bill. I was lucky enough to get a Codex promo code, so I ran this for free under promotional subscription limits. Those limits are doubled only until the end of May 2026, and starting from June 2026, they should drop back to roughly half of what I had during this test. The dollar numbers are only there to compare the token spent in a more familiar way. The quota screenshots point in the same direction, but the logs are better evidence. GSD was much heavier, OpenSpec was much cheaper to run. GSD made a stronger case for code quality because it left behind tests, type check, better configuration, and cleaner project scaffolding. My personal choice for this kind of work would be OpenSpec. That does not make OpenSpec the better framework in every sense. It is not. GSD produced a stronger repo. If you care about quality checks, verification, and letting the framework manage more of the engineering process, GSD has a real argument. It is much closer to what I wanted BMAT to be: structured, autonomous, and capable of doing work instead of asking me to approve more documents. For my own working style, OpenSpec is easier to live with. I like fast iterations. I like being able to prompt, check, adjust, archive, and move on. I do not want every small correction to become a large process. OpenSpec gave me that. It was fast enough that I stayed engaged with the work instead of mentally switching away for half an hour and coming back to inspect whatever happened. GSD is better when you want bigger autonomous chunks. Set it running, wait for the sound, come back, review the result. That is a valid workflow, and for some people it will be better. Less technical builders might prefer it because the framework owns more of the planning and verification. Teams evaluating these tools might also care more about the stronger repo baseline than about my personal impatience. And I should be fair to GSD here. This test still felt like it covered only a small part of the framework. It has advanced features and configuration options underneath that I did not properly explore in this comparison. So if you want a dedicated GSD video, let me know in the comments. There is clearly more there than one side-by-side build can cover. By the way, I'm also very curious how both frameworks would behave with something like Composer 2 Fast. Composer 2 is very fast, so the whole process would probably feel snappier even with GSD. Maybe GSD would not feel nearly as slow in that setup. A lot of this comparison is GSD versus OpenSpec through a specific stack. The framework, the coding tool, the model, and the limits all working together. Change one part of that stack and the trade-off can move. So the practical recommendation is simple. If you can own the roadmap yourself and you want speed, start with OpenSpec. If you want the framework to manage more of the process and you're willing to spend more time and tokens for better quality gates, try GSD. I pushed both generated repos publicly so you can check them yourselves. The links are in the description and on the screen. And for the final benchmark, my cat would obviously choose OpenSpec. Once she requests dinner, she does not expect a 5-phase execution plan while the bowl is being prepared. She expects the result immediately. Faster is better, and frankly, her acceptance testing is harsher than mine.